Welcome to the Deep Dive, where we sift through the latest research to unearth those aha moments you won't find anywhere else.
Great to be here.
Today, we're plunging into a discovery that could, well, fundamentally reshape our understanding of early human ingenuity.
It really could.
Imagine this. A tiny, unassuming piece of stone, maybe the size of your thumbnail, found at an archaeological site. Yet it's poised to rewrite a pretty significant chapter in human history.
Yeah.
That's the electrifying question at the heart of our deep dive today.
It's a truly groundbreaking study, particularly because it challenges some long-held assumptions.
Right.
We're talking about a fascinating new analysis from Uzbekistan, focusing on a site called Obi-Rakhmat.
Obi-Rakhmat, yeah.
And researchers there have uncovered incredibly old projectile points, specifically what they're calling micropoints.
Micropoints.
Yeah, dating back a staggering 80,000 years.
80,000, wow. Okay, so our mission today is to understand why these tiny tools are making such big waves, archaeologically speaking.
Exactly. What do they really tell us?
Yeah, what do these micropoints tell us about early hunting technology? How do they shed new light on the capabilities of our ancient ancestors?
And the big one.
And perhaps most importantly, how do they sort of challenge our current understanding of major transitions in human prehistory? You know, that whole shift from the Middle to Upper Paleolithic.
Let's set the scene a bit. Our story unfolds at the Obi-Rakhmat rock shelter. It's nestled in the Paltau Valley, Tien Shan Mountains, northeastern Uzbekistan.
Okay, quite a location.
Yeah, about 100 kilometers from Tashkent. And this isn't just any old dig site. It boasts an impressive 10 meters of exposed stratigraphy.
10 meters, that's deep.
It is, and it reveals this rich archaeological timeline stretching from about 90,000 all the way down to 40,000 years ago.
Incredible range. And the teams involved, you said University de Bordeaux and Novosibirsk.
That's right. They didn't just, stumble upon these things. They undertook a very meticulous traceological search.
Traceology. Can you remind us what that involves?
Sure. It's basically the specialized study of microscopic wear patterns, residues on ancient tools. It reveals how they were actually used.
Ah, okay. The how.
Exactly. And they specifically focused on the oldest layers of the site, layers 20 and 21. Painstaking work, really.
Sounds like it.
They examined 194 point specimens and 193 small triangular flakes. Just shows incredible attention to detail.
Definitely. So what came out of that meticulous work?
Well, what's truly remarkable is what emerged. Out of all those hundreds of pieces, 20 were confidently identified as possible projectile armatures.
20 potentials, okay.
And they seem to fall into three distinct classes. First, they found these larger, more robust points.
Heavier ones.
Yeah, weighing between, say, 25 and 35 grams, about 38 to 41 millimeters wide. The impact marks on these, they're entirely consistent with use as spear tips or maybe dirt tips.
Okay, that fits what we might expect. What else?
Then there were bladelets, smaller. These are thought to be used as, lateral inserts in a composite weapon.
Ah, so part of a more complex tool.
Precisely. They show this discrete crushing pattern, also consistent with projectile use. So this suggests sophisticated hunting weapons were around as early as 80,000 years ago.
That's significant in itself.
It is. But the real star of this archaeological show, the find that's truly shaking things up, are these micropoints.
The micropoints. Tell us about them.
Okay, so these are tiny, usually unretouched triangular flakes, average width, just 18.2 millimeters.
Tiny.
And they weigh about 1.4 grams on average. Think about a paperclip's weight.
Wow. That's incredibly light for a weapon point.
It is. And crucially, two specimens even showed both these longitudinal stress fractures and something archaeologists call microscopic linear impact traces, MLITs.
MLITs. That sounds important.
It's basically unequivocal evidence of high-force, high-velocity impact.
Okay. So they definitely hit something hard and fast.
Yes. And here's where the researchers made their most, striking deduction.
Go on.
Based on the almost microlithic shape of these micropoints, their initial hypothesis led them to a startling conclusion.
Which was?
That these tiny tools are, and I'm quoting here, technically unsuitable for mounting on anything other than arrow-like shafts.
Arrow-like shafts. So arrowheads. 80,000 years ago.
That's the implication. Arrowhead.
But how do you get there?
Yeah.
How do you go from a tiny flake, even with impact marks, to such a definitive claim like arrowhead? That seems like a big leap.
It does, and that's the critical challenge, isn't it? Because simply looking at a tool shape, Well, it isn't enough to determine its function, not reliably, especially when you're talking about something so ancient.
Right. Looks can be deceiving.
Exactly. And this is precisely where the rigor of traceology came into play. The researchers used this multifaceted approach,
Okay.
combining naked eye identification, high-powered stereoscopic microscopy, and reflective optical microscopy
All of it gear.
to identify those telltale MLITs, the specific patterns left only by high-velocity impacts.
But they didn't just stop at looking under microscopes, did they? I bet they did something else.
No, they didn't, and that's what makes this study so compelling, I think. They went a step further. They conducted these ingenious experimental archaeology tests.
Experiments. How?
Well, they painstakingly reproduced these tiny tools using local stone silicified limestone, the same stuff found at the site.
Okay, making copies.
Then they attached 12 of these replica micropoints to 8mm diameter commercial wooden arrow shafts.
Right.
And here's a crucial detail. They didn't use modern string or anything. They mimicked ancient techniques using bitumen and charcoal glue to fix them.
Ah, like they hypothesized the originals were attached?
Just like that. Then came the real test.
Would they shoot them at?
They shot these replicas from a 36-pound bow of fairly primitive bow strength at an uneviscerated small ungulate carcass.
A real animal carcass. Wow.
Positioned to simulate a real hunt scenario. And this allowed them to meticulously document how these specific tools broke on impact, how deep they penetrated, and crucially, what kind of MLITs were created under these controlled conditions.
So they could compare the experimental damage to the damage on the ancient points.
Precisely. Which leads to the big question they had to answer, and for us too. Why are they so convinced these were arrows, specifically? Not heavier spears or, say, darts thrown with an atlatl. What's the fundamental difference that points to arrows?
Yeah, good question. Because spears and darts existed then too, right?
Oh, absolutely. But it all comes down to the physics and the design principles of these different hunting weapons.
Okay. Explain it.
First, just consider the sheer size and weight. We said 1 to 2 grams, right?
Paperclip weight, yeah.
They simply weren't designed structurally to withstand the violent, high-momentum impacts you get from heavier spears or even darts. They'd likely just shatter on impact without penetrating deeply enough.
Okay. Too fragile for that kind of force. What else?
What's more, their shape, that triangular form with the prominent bulb of percussion where it was struck off the core, made traditional lashing or binding methods really difficult.
You couldn't tie them on easily.
Probably not effectively, which strongly suggests they were glued to the shafts, like in the experiments.
Right.
And if they're glued, the shafts themselves would have had to be significantly narrower than the point's maximum cutting width for it to work properly.
Why narrower?
Well, think about how an arrow works, especially from a relatively low-power bow. For these low-momentum projectiles, it's the point's width and sharpness, its ability to cut and tear the skin, that are far more critical than its weight.
To initiate the wound.
Exactly.
Yeah.
That allows the shaft itself, the thin shaft, to follow through and provide the penetrative force deep into the animal.
That's a crucial distinction from a heavy spear point that relies on mass and momentum.
Precisely. And here's the clincher. When you look at modern and ethnographic examples of arrows from various cultures, traditional arrows, their shafts consistently hover around a 7 to 8mm diameter.
Okay, standard arrow shaft size.
Now, what's astonishing is that the calculations based on the Obi-Rakhmat micropoint's frontal outline, which dictates the maximum possible shaft size you could fit behind it, suggest a potential shaft diameter of 7.5 to 8mm.
Whoa, that's a near perfect match.
It's like finding an ancient engineering spec sheet, isn't it? It aligns incredibly well.
Amazing. So the physics, the size, the potential shaft diameter, all point towards arrows.
Yes. And to really solidify their argument, the researchers meticulously refuted alternative hypotheses, just to be thorough.
Like what? What else could they have been?
Well, someone might say maybe they were just child-sized weapons or toys.
Mm-hmm.
But the researchers emphasize these micropoints required genuine skill, real know-how to nap properly. They weren't simple flakes.
Not kid stuff.
And importantly, their impact traces showed they effectively penetrated soft tissue before breaking, proving they were functional hunting tools, not just toys.
Okay, so functional.
Yeah.
What about other small projectiles like blowgun darts?
Good point. They considered that too. But ethnographic blowgun darts are typically much, much lighter, usually less than a gram, and often needle-like.
Right.
The Obi-Rakhmat micropoints, at 1.4 grams average and being relatively wide flakes, are just disproportionately large and heavy for that kind of use. It doesn't fit.
Doesn't fit the blowgun profile.
Yeah.
Okay, so With all this evidence piled up, the traceology, the experiments, the physics, ruling out alternatives, what's the final word from the study?
The conclusion is pretty firm. Regarding these specific micropoints as arrowheads is the working hypothesis that is, again quoting, most compatible with the fundamental principles of hunting weapon design and with the available experimental references.
It sounds like a really compelling case they've built. Okay, so let's zoom out. Assuming this is correct, 80,000-year-old arrowheads, what are the broader implications? What does this discovery at Obi-Rakhmat mean for our understanding of ancient human ingenuity and, well, our history?
It's huge. If we connect this to the bigger picture, it really represents a significant technical break from what we've generally seen before in that time period.
How so?
Well, we know earlier evidence for projectile points exists. You've got finds from South Africa maybe around 500,000 years ago, Ethiopia over 279,000 years ago, maybe Israel around 180,000 years ago.
Right, we knew about spear points.
Yes, but those were typically larger points, often multifunctional tools, maybe used as knives sometimes, spear tips other times. They simply don't show this same kind of specialized, lightweight projectile design optimized for potentially archery that we see at Obi-Rakhmat.
So it points to a different kind of hunting strategy, maybe tackling different prey or in a different way.
Possibly, or at least adding a new, very sophisticated tool to the toolkit. And this really puts the capabilities, or perceived capabilities, of Neanderthals into sharp relief.
Ah, the Neanderthal question. How does this fit in?
Well, for a long time, that middle to upper Paleolithic transition, around 40, 50,000 years ago, was often framed as this sharp, almost biologically driven shift. The idea was Homo sapiens arrived with superior cognitive abilities, better technology, including advanced projectile weapons.
That Neanderthals supposedly lacked.
Right. But the combination of diverse projectile armatures found at Obi-Rakhmat, especially including these microlithic ones, these potential arrowheads, at 80,000 years ago. The paper states this does not fall within the Neanderthal repertoire as we currently understand it from other sites.
Even Neanderthal sites from around the same time or even later?
Exactly. Sites like Boheben or Biache-Saint-Vaast in France, which are Neanderthal sites, don't show this kind of specific technology. So Obi-Rakhmat presents a real puzzle in that context.
Okay. But then there's another comparison they make, isn't there? Something about a cave in France.
Yes. This is truly fascinating. They highlight a striking similarity to findings way over at Mandrin Cave in France.
Mandrin Cave, what did they find there?
Micropoints described as identical to those found at Obi-Rakhmat, also showing impact damage consistent with projectile use, and also interpreted as arrowheads.
Identical points. Okay, but when?
Here's the astonishing part. Mandrin Cave is dated to around 54,000 years ago. That's 25,000 years later than Obi-Rakhmat.
25,000 years later on the other side of a continent.
And crucially, at Mandrin, these points were found alongside a Homo sapiens tooth.
Ah, a Homo sapiens link.
A direct link, yeah.
So what does that similarity suggest across such a vast distance and time gap?
It really fuels the idea that these early complex weapon systems, specifically this kind of light projectile technology, might represent a new technical lineage.
A technical lineage.
Yeah.
Like a tradition.
Sort of. Think of it like a distinct branch on the evolutionary tree of human tools and techniques. It's not just a one-off invention at Obi-Rakhmat or Mandrin.
But a shared idea, a design philosophy almost.
Exactly. A fundamental approach that maybe got started, perhaps was initially added on the margins of pre-existing production systems, as the paper puts it.
Okay.
But because it was so effective, so important, it eventually really influenced sapiens' technological conceptions. It became a hallmark, almost like a cultural or technical signature.
Interesting. It paints a picture of innovation spreading, or maybe being rediscovered or carried by people.
It does. And to try and tie it together geographically, remember where Obi-Rakhmat is? Northeastern Uzbekistan. That puts it on the northeastern periphery of what scientists increasingly call the Persian Plateau.
The Persian Plateau. Why is that area significant?
Well, recent genetic data suggests this broad region, think Iran, parts of Central Asia, might have been a crucial population hub for all non-Africans between about 70,000 and 60,000 years ago.
A hub? Like a crossroads or a place people stayed for a while?
Sort of a staging ground, perhaps, after leaving Africa but before spreading further into Eurasia. It was likely a resource-rich environment.
Okay.
And such an environment could have fostered significant interaction between different groups, maybe leading to the exchange of ideas, the development of technical innovations.
Like advanced projectile weapons?
Potentially. It's one hypothesis for how such technology might have developed and then spread outwards from the central hub.
Okay, that provides a possible geographic and demographic context. But it brings us back to the really tricky question. Who exactly were the hunters at Obi-Rakhmat 80,000 years ago?
The ancestral enigma, right? And this is where it gets even more complicated. Human remains have been found at the site.
They have? What kind?
Specifically, parts of a juvenile individual, maybe 9 to 12 years old, from layer 16. And that layer dates to about 70,000 years ago, so broadly contemporary with the older tool layers.
Okay, a hominin from the right period. So Neanderthal, sapiens.
And here's the twist. While the teeth, the dental morphology lean towards Neanderthal,
Okay.
the cranial features, the skull fragments, are described as ambiguous. They don't scream classic Neanderthal.
Ambiguous, so what did that mean?
It leaves open the classification. Some might interpret it as archaic Homo sapiens, or maybe even a hybrid population. We just don't know for sure based on the morphology alone.
Wow. Okay, so we have potentially sapiens-like technology, these arrowheads,
Right.
but the actual human remains are ambiguous, maybe leaning Neanderthal.
Exactly, and that raises a really profound question, doesn't it? If complex, diversified projectile weaponry, especially this arrow-like tech, is often considered a specific marker for Homo sapiens, and we find it at Obi-Rakhmat at 80,000 years ago alongside these ambiguous remains, what does that mean for our neat and tidy story of the Middle to Upper Paleolithic transition?
It throws a wrench in it, basically. Does it mean Homo sapiens were definitely there much earlier than we thought in Central Asia? Or does it mean that some Neanderthal groups or related groups were far more technologically advanced, more modern in their behavior than we typically give them credit for?
Those are the key questions. The study itself suggests maybe we need to rethink the whole transition. They propose reformulating it not in biological terms,
Not just about species replacement.
but in relation to the steps in the trajectory of AMH, anatomically modern humans, probably of a demographic nature.
Okay, unpack that a bit. Demographic nature.
It pushes us to think less about some sudden biological upgrade where sapiens just outsmarted everyone else overnight. Instead, maybe we should focus more on population dynamics.
Like how groups interacted, grew, maybe moved around.
Yes. How population growth, resource pressures, environmental changes might have driven interactions, the sharing or independent development of innovations, creating a more continuous, maybe messy, flow of cultural and technological development, rather than sharp species-based divides.
A more fluid picture of innovation and change.
Perhaps. For now, though, the lack of, say, ancient DNA or protein analysis on that Obi-Rakhmat hominin fossil leaves the biological identity question tantalizingly open.
We need more data from the bones themselves.
Absolutely. But its resolution, finding out definitively who that individual was, will be, as the paper says, of the utmost importance to the debate on the roots of the IUP, the initial Upper Paleolithic.
A critical piece of the puzzle still missing. Okay, so let's recap our deep dive into Obi-Rakhmat. We've looked at these really astonishing findings, potential 80,000-year-old arrowheads,
Truly remarkable finds.
pushing back the timeline significantly for complex hunting technology. And we've explored the meticulous science behind it, the traceology, the experimental archaeology that really seems to firmly support these groundbreaking claims.
Yeah, the methodology is really impressive. Looking ahead, what happens next with this?
Well, these tiny micropoints are probably going to become what archaeologists call an index fossil,
A marker.
a definitive marker for this kind of early complex hunting technology. Future work at Obi-Rakhmat will likely investigate their persistence. Do they appear in younger layers too? How long was this tech used there?
And beyond Obi-Rakhmat.
Well, it's quite possible, now that researchers know exactly what to look for, that discoveries of similar points might start appearing in other sites from this period.
Across a wider region.
Yeah, maybe stretching from Central Asia, perhaps further east, maybe even eventually linking up towards the west, toward the Mediterranean, thinking about that Mandarin Cave connection again.
Right, which raises that fascinating question for future research.
Was Obi-Rakhmat a recipient of this cultural complex? Did the idea arrive there through migration or exchange? Or was it perhaps an originator, a hub where this advanced technology first emerged and then spread?
We don't know yet.
We don't. And maybe thinking about these ancient connections across vast distances and huge stretches of time, hinted at by shared technologies like these tiny arrowheads, How does that reshape our understanding of our own species' past?
Hmm.
It suggests maybe a more complex, interconnected story, doesn't it? A mosaic of interactions, innovations popping up, spreading, maybe disappearing and reappearing, rather than just a simple linear progression from primitive to advanced.
A much richer, more dynamic picture of human ingenuity.
Exactly. And it leaves you wondering, what other hidden signatures of human ingenuity, what other tiny clues, like these micropoints, are still out there, waiting to be uncovered just beneath our feet?